Hey everyone, this is Group 5 and today we are going to discuss about oxidation reduction reaction, and we are going to determine how factors such as pH, temperature, and substrate affect enzyme activity. In redox reaction or oxidation reduction reaction, this is the transfer of electrons. It says here a reaction involving electron transfer. Specifically learn about oxidation and reduction. Oxidation, this is the loss of electrons, which causes an increase in oxidation state, while in reduction, this is the gain of electrons, which causes a decrease in oxidation state. If you are still confused about oxidation and reduction, here are some couple things that will help you to keep in mind. The first one is oil rig. Oil is oxidation is loss, and rig is reduction is gain. The other one is Leo the lion's ger. Leo is loss of electrons is oxidation, and ger is gain of electrons is reduction. If you guys are probably wondering why a reduction is gaining an electron, that's because an electron has a negative charge. So as you add an electron, its charge goes down. The more electrons you add, the charge reduces or decreases. Now let us know how oxidation and reduction works. But first, let us have a recall. Oxidation means it's losing an electron, while in reduction, it's gaining an electron. As you can see in the first picture, A is giving its electron and B is obtaining the electron. Now let us know where is oxidation there and reduction there. Oxidation has taken place in A because A is losing its electron. A is being oxidized. Reduction has taken place in B because B is gaining an electron or getting an electron. B is being reduced. Oxidation is in A and reduction is in B. Now let's move to the second picture. We can see that there is an equation in there. That's because oxidation and reduction can be shown to an equation. And we can see at the lower part there is a half reaction word, owing to the fact that either oxidation or reduction are half reaction. Now let's start with the Cl that is being reduced. So Cl plus A minus, then we get Cl 1 minus. A is for the electrons, and for the minus sign there, I think that's because electrons has a negative charge. We notice that the equation for oxidation is different to reduction. That's because Na, its electron, is being spit out, while in reduction, in chlorine or Cl, it's gaining an electron. That is why its equation is like that. Whole equation, Na plus Cl or sodium plus chlorine, we get sodium chloride or table salt. That is all for the oxidation reduction reaction or redox reaction. Now let's move to the 6 types of redox reaction. They are combination reaction, decomposition reaction, single replacement reaction, double replacement reaction, combustion reaction, and disproportionation reaction.
So this lesson that we're going to discuss is all about type of oxidation reduction. First, we have combination reactions. It is a reaction where 2 or more elements or compounds combine to form a single compound or product. Combination reaction may occur between 2 elements, 2 compounds, or between a compound and an element. So from the word combination, it's like a mix or pair. So here's the example. Based from the example, A plus B is equal to AB, or maybe magnifying plus glass is equal to magnifying glass. It's a process of combining elements using 2 or more substances to form a new product. And take note, the product will always be a compound. So a while ago, my example is just an example from me, given by me. and it's not kind of substances that one in periodic table. So second is the composition reaction, which is the reverse of a combination reaction or chemical breakdown. Is a two or more compound that breaks into individual elements. So as we can see in the example, chemical compounds separated from each other. That's what we call decomposition. It is the process or effect of simplifying a single chemical entity into two or more fragments. So next, we have single replacement reaction or exchange reaction. It is a reaction in which one element replaces a similar element in a compound. So based from the example, it is the substitution from one compound to another.
In double displacement reaction or double replacement reaction, this is the exchange between two compounds. In these reactions, it occurs when two cations and anions swap places. In writing the double replacement reaction, we must write the cations first, then the anions. Cations are the positive ions and anions are the negative ions. We can see that D and B switch their places. D is associated with A and B is associated with C, meaning that the double replacement reaction has occurred and it produced two new compounds.
Combustion reaction is the formal terms for burning and typically involves substance and reacts with oxygen to transfer energy to the surrounding as light and heat. Combustion reaction always involve oxygen and anorganic fuel. Example of combustion reaction: a redox process, methane CH4 reacts with oxygen O2 to form carbon dioxide CO2 and two water molecules 2H2O, and this is the example of combustion reaction. Disproportionation reaction: a single substance can be both oxidized and reduced. One example of such process is the reaction of hydrogen peroxide H2O2 when it's poured over a wound. At first, might look like a simple decomposition reaction because hydrogen peroxide breaks down to produce oxygen and water. This reaction lies in the oxidation state of oxygen. However, notice that oxygen is present in the reactant of both products. In H2O2, oxygen has an oxidation state of -1. In H2O, its oxidation state is -2, and it has been reduced in O2. However, its oxidation state is 0, and it has been oxidized. Oxygen has been both oxidized and reduced in the reaction, making this a disproportion reaction.
Now let's determine how factors such as pH, temperature, and substrate affect enzyme activity.
pH. Each enzyme has an optimum pH range. Changing the pH outside of this range will slowly enzyme activity. Extreme pH values can cause enzyme to denature. The pH scale is used to measure the acidity or alkalinity of a sample and describes how many hydrogens, ions, or hydroxides are present in the sample. The change of pH will lead to the ionization of amino acids, atoms, and molecules. Change the shape and structure of proteins, thus damaging the function of proteins. Enzymes are also proteins, which are also affected by changes in pH. Very high or very low pH will lead to the complete loss of the activity of most enzymes. The pH value at which the enzymes is most active is called the optimal pH value. pH affects enzyme activity. The structure of the enzyme has a great influence on the activity of the enzyme. In other words, changes in the structure of the enzyme affect the rate of chemical reactions. When the pH value of the reaction medium changes, the shape and structure of the enzyme will change. For example, pH can affect the ionization states of acidic or basic amino acids. There are carboxyl functional groups on the side chain of the acidic amino acids. There are amine-containing functional groups in the side chain of basic amino acids. If the ionized state of amino acids in the protein is changed, the ionic bonds that maintain the three-dimensional shape of the protein will change. This may lead to changes in protein function or inactivation of enzymes. Enzymes are also sensitive to pH. The changing the pH of its surroundings will also change the shape of the activity site of an enzyme. Many amino acids in an enzyme molecule carry a charge within the enzyme molecule. Positively and negatively charged amino acids will attract. This contributes to the folding of the enzyme molecules, its shape, and the shape of the active site. Changing the pH will affect the charges of an amino acid molecules. An amino acids that attracted each other may no longer be. Again, the shape of the enzyme along with its active site will change. Extreme of pH also denature enzymes. The changes are usually, though not always, permanent. Enzymes work inside and outside cells. For instance, in the digestive system where cell pH is kept at 7.0 pH to 7.4 pH, cellular enzymes will work best within this pH range. Different parts of the digestive system produce different enzymes. These have different optimum pHs. The optimum pH in the stomach is produced by the secretion of hydrochloric acid. The optimum pH in the duodenum is produced by the secretion of sodium hydrogen carbonate. The following table gives example of how some of the enzymes in the digestive system have different optimum pHs. For examples, enzymes in the small intestine have an optimum pH of about 7.5, but stomach enzymes have an optimum pH of about 2, graphing that as the pH increases, so does the rate of enzyme activity. In the graph above, as the pH increases, so does the rate of enzyme activity. An optimum activity is reached at the enzyme's optimum pH. pH 8 in this example, a continued increase in pH results in a sharp decrease in activity as the enzyme's activity site changes shape. It is now denatured.
The rate of an enzyme catalyzed reaction increases with temperature, as it does with many other chemical reactions. At high temperatures, the rate slows again because the enzyme becomes denatured and no longer functions. As temperature increases, so do the rate enzyme reactions. A 10 degrees centigrade rise in temperature will increase the activity of most enzymes by 50% to 100%. Variations in reaction temperature as small as 1 or 2 degrees may introduce changes of 10% to 20% in the results. Over a period of time, enzymes will become inactive at lower temperature, but will regain most of their activity when temperature rises again. Collisions between all molecules increases temperature increases. With faster velocities, there will be less time between collisions. Since the molecules are moving faster, collisions between enzymes and substrates also increases. Too much heat can cause the rate of an enzyme catalyzed reaction to decrease. The optimum temperature for enzymes is about 98.6 degrees Fahrenheit or 37 degrees Celsius. There are enzymes that work well at lower and high temperatures. Like all proteins, enzymes begin to break down at temperatures above 104 degrees Fahrenheit. The range of enzyme activity is determined by the temperature at which enzymes begin to activate.
Hi, my name is Angeline J. Mamigo. Now, let's talk about how substrate affects the enzyme activity. Enzyme will work best if there is a plenty of substrate. As the concentration of substrate increases, so does the rate of enzyme activity. However, the rate of enzyme activity does not increase forever. This is because a point will be reached when the enzyme becomes saturated and no more substrate can fit at any one time, even though there is a plenty of substrate available. As the substrate concentration increases, so does the rate of enzyme activity. An optimum rate is reached at the enzyme optimum substrate concentration. A continued increase in substrate concentration result in the same activity as there are not enough enzyme molecules available to break down the excess of substrate molecules.